Hello everybody, welcome back to the channel. In this video, we're going to talk about how we can write radicals in simplest form. So at the top it says an expression involving a radical with index n is in simplest form when these three conditions are met. So this is kind of our checklist here. We need to meet all three of these conditions. Number one, no radicands have perfect nth powers as factors other than 1. So if we remember, the radicand is going to be our number under the radical in that place right there. So for example, if I had an 81 in there, well, we know that 81, and if I was taking the square root, we know that 81, well, that's a perfect square, right? So we would need to simplify that to positive or negative 9. But for example, if I had the square root of 3, well, we know it doesn't have any other perfect square factors other than 1, so it would satisfy that first statement. No radicands contain fractions. So if we look at our two examples we have over here, if we had, for example, the square root of 1/4, we can't leave that. We would have to simplify that. And number 3, no radicals appear in the denominator of a fraction. So we can't have, or we can't leave, like the square root of 2 divided by the square root of, let's not do 4, square root of 3, right? So we can't have a radical in the denominator. It says to meet conditions 2 and 3, sometimes we might need to rationalize the denominator by multiplying the expression by an appropriate form of 1 that eliminates the radical from the denominator. So we're going to look at two examples where, well, really just one example where we don't have a denominator, and then on the last 3 examples, we're going to have to rationalize this denominator to make sure our radical is out of the denominator. And if you notice on numbers 3 and 4, we have a sum or a difference in our denominator, so we're going to have to use what's called the conjugate to be able to rationalize that denominator. So we're going to get 4 good examples in this video. So for number 1, we have the cube root of 500. So one thing we want to make sure of, does 500 have any perfect cube factors? Well, if we think about the factors of 500, 125 is a factor of 500. And why am I saying 125? Well, because 125 is a perfect cube. So we could rewrite this as the cube root of 125 times the cube root of 4, because 125 times 4 gives us 500. So now the cube root of 125 is 5, and we can write this as 5 cube root of 4. All right, number 2, we have the 4th root of 19 divided by the 4th root of 4. So in this case, I want to multiply by the same term on the numerator and the denominator, because that's going to be an appropriate form of 1, right? If I divide the same thing, it's going to give me 1. And now I'm thinking, okay, the denominator is the 4th root of 4. So what can I multiply 4 by for it to become a perfect 4th root factor? Well, I'm thinking of 16, because the 4th root of 16 is 2. So if I multiply this by the 4th root of 4, and if I multiply the numerator and the denominator, I'm not changing the value of this expression because we're just multiplying by 1. So now on the top, I can do 19 times 4, and that gives me the 4th root of 76. And on the bottom, I do the 4th root of 16. And so now we can simplify this because the 4th root of 16 is just 2. So our answer would be the 4th root of 76 divided by 2. All right, number 3, we have 1 divided by the square root of 7 minus 2. So we are going to multiply the top and the bottom by the conjugate, which would be the square root of 7 plus 2. Square root of 7 plus 2. So we do this because it's essentially us setting up what we call the sum and difference pattern, and that's going to lead us to a squared, or our first term squared. So the denominator, first term square root of 7 squared would just be 7, minus our second term squared. So 2 squared would be 4. And then in the numerator, we just distribute that 1, and it's going to end up being square root of 7 plus 2. And now we can simplify our denominator. 7 minus 4 is 3. So our final answer there would be root 7 plus 2 divided by 3. All right, number 4, we have 3 divided by 6 plus root 2. So once again, we're going to multiply by what we call the conjugate. So instead of 6 plus root 2, it's going to be 6 minus root 2. And whenever we multiply the denominator by, we have to multiply the numerator by, because that is us multiplying by 1 and not changing the value of the expression. So once again, our denominator is going to be our first term squared, so 36, minus our second term squared, which would be 2, because the square root of 2 squared would be 2. Now in the numerator, we're going to distribute. So 3 times 6 would be 18, and minus 3 times root 2 would be 3 root 2. Now we could simplify the denominator. 36 minus 2 is 34. So that would give us a final answer of 18 minus 3 root 2 divided by 34. And that would be our final solution there. And that's how we can make sure we have our radicals written in simplest form.